Okay, so we are on lesson 5. How excited are you guys? Okay, so this is kind of a shorter lesson for you for a shorter week, so you're gonna love it. A little bit easier, but we're gonna learn why do objects fall down when dropped. So make sure you get your paper out and get it ready, and let's go through this packet together. So your objective is I will support an argument to explain the gravitational forces of the earth. Now, people live all over the world. Obviously, we know that. We know that the earth is a sphere shape. We learned that in the last lesson. And people live on land all around this sphere. But what direction is up and what direction is down for people who live in different parts of the world? Okay, so I'm going to give you something to make you think. My sister was a foreign exchange student in New Zealand, okay? And New Zealand is in the southern hemisphere, whereas we're in the northern hemisphere. Let me just show you. Okay, so here we go. Here is New Zealand, down here in the southern hemisphere. Here is the United States, right up here, okay? Let me make sure that's, yes, that's the United States. Okay, so we're in the northern hemisphere, and she was in the southern hemisphere. Now, granted, night and day was a little bit different timing there, but when I told her to go out and look at the moon, I said, go out and look at the moon tonight, and you tell me what side of the moon was lit up. And she emailed me back and she said, Chrissy, the right side of the moon was lit up. Well, that very same night, I looked and the left side of the moon was lit up. It's the same moon we're looking at. But why was she seeing the right side of the moon lit up and why was I seeing the left side of the moon lit up? Okay, so this concept is a little bit hard to grasp, but once you grasp it, you're gonna get it and you're gonna understand. So just stay with me. So grab your piece of paper, okay? And then I want you to cut out the 4 people. You can see there's tons more people you don't need. You just need 4 of them. Okay, so now you're gonna take your 4 little people and I want you to place them on each of the 4 continents how you think that they would be standing on the continent, okay? So I want you to hit pause. I want you just to place them. Don't glue them yet. I just want you to place them where you think they're gonna go. Or if you're doing the drawing, if you can't cut and glue, I want you to just draw some stick figures, okay? But hit pause. Okay, so I'm gonna take each of our 4 people and we're gonna place them, okay? So we're gonna place this one right here. I know you're thinking, Miss Nutter, that's not right, but trust me, I'm right, okay? And then we're gonna place this person down here in the Antarctic, and then we're gonna place this person right here, okay? So I want you to glue those into place, okay, or get that drawn, all right? We're gonna come back to this page, but we're gonna leave this for just now. So which way is down? We are now on page 2. Even though it looks like some of the people on page 1 are standing upside down, it doesn't feel like that to them. No matter where someone is standing on earth, they feel like they're standing right side up. When people around the world drop objects, they fall down to the ground. But which way is down for people in different places on earth? Draw an arrow to show the directions that each of the objects below would go when dropped. Okay, guys, which direction is this pencil gonna go? It's obviously gonna go down. Which direction is this one gonna go? Down. Which one is this one gonna go? Down. What about this one? Down. Okay, so now we're gonna turn back to page 1. Draw an arrow on the globe at locations 1 through 4 to show which way is down for each person and label each arrow down. Okay, so looking at this guy right here. In page 2, you showed the paintbrush going down. So which direction would it go? It would be showing it going down, right? Now, on this guy right here, which way is the apple gonna go? It's gonna go down, okay? So when you do this for all of your people, where, even this person upside down, which way is the pencil gonna flow, okay? Is the pencil gonna go up? No, it went down to her feet, right? So if you look here, it's gonna go down to her feet, all right? If you have your people in different positions, that's perfectly okay, all right? So if you notice, where are all the directions pointing down to? The center of the earth. Okay, question number 2. are the arrows representing down for each person facing the same way on page 1. So they're all going straight down on this page, but are they all going in the same direction on this page? No, the arrows are all going in, pointing toward the center of the earth. So your answer to number 2 is going to be no. Question 3 says, how can you describe what direction down is for the people in different locations of the earth? If we go back and we look, down is pointing to the center of the earth, okay? So down for each person is towards the ground and towards the center of the earth. You can pause and write that down. Okay, so now number 4, it says up is the direction opposite of down for each person. Draw an arrow and label it up for each person on page 1. So you're going to go back to page 1 and you're going to draw the up arrows, okay? Okay, kids, the key idea here is if the earth is a sphere and all people around earth see objects falling to the ground when dropped, then down is towards the center of the earth. Okay, so I've got my globe. All right, just kidding, it's Miss Morris's globe. All right, so I've got my man here. Where is the center pulling? It's pulling it down into the center of this globe, okay? So then I have my other man. He's down here. And his feet are being pulled to the center. Like if you pretend the very center of this, like if it's a cake, it's the filling on the inside, okay? Being pulled to the center. So we're here, okay? Now, just for purposes, okay? This person, the moon, guys, is like right here, all right? It's right out here. So this person is looking out into the night sky and they're seeing the right side of the moon lit up, where this person is sitting off to the left-hand side, or seeing the left-hand side of the moon lit up. So they're seeing completely opposite because they're looking at it from different angles, okay? So here's another way you can pretend to do this. Have somebody lay on the floor next to a bed, okay? And then have somebody on top of the bed and looking over. So your head is here and their head is here, all right? And if you were to put an object there and you ask them which side something was on, they are going to tell you opposite sides because you're looking at it from different perspectives. Ready to activity 2. So gravity causes objects to fall down. When you drop an ice cream cone, it splats to the sidewalk. Rain falling from a cloud falls to the ground. Even objects you throw upward eventually fall back down to the earth. What makes things fall to the ground? The answer is gravity. Gravity is a force that pulls on objects. All objects have their own gravitational pull, but objects with more mass have more gravitational pull. Because the Earth is much more massive than objects around it, Earth's gravity is very strong. Earth pulls objects on or near the Earth toward itself. So how do we know that the Earth's gravity exists when we can't see it? Even though we can't see gravity, we can see its effects on objects. If you hold a ball still and let it go, it moves downward. Something must be acting on it to make it move, or it would just stay exactly where it was. Earth is pulling the ball toward itself. So if you notice, everything's being pulled to the center of the Earth, okay? Because the Earth's gravity is always pulling objects towards its center, the directions of up and down are compared to where you are on Earth. Down will always be toward the center of the Earth, and up will be always in the opposite direction. So here it says Earth's gravity pulls objects towards its center so that they fall to the ground. All right, so let's look at number 1. Circle all the statements below that are true about gravity. Gravity is a pushing force. We didn't talk about pushing. We learned that it was a pulling force, right? So that is false. So objects with more mass have more gravitational pull. Did we just read about that? Absolutely, because the Earth is so big, it has a great gravitational force. Now, up and down depend on your location on the Earth. That is true as well, because when you're looking here, it depends on your location, because someone's up and down here is different from someone there. So that statement is true, all right? So gravity is a pulling force. We just discussed that one is true. Down is towards the center of the earth. Did we get that that was true? Absolutely. Down is always towards the South Pole. So is down always pointing down here to the South Pole? No, it's always pointing to the center, so that one was false. So you should have circled all of them except for these last two, or these two, sorry. Okay, so question 2. Look at the 4 objects below. A building, the moon, a basketball, and the mountain. Put the objects in order from having the most gravitational pull to the least gravitational pull. Okay, so we have to know some background knowledge for this. Objects with a bigger mass have a greater gravitational pull. So put those in order based on their mass. Okay, so you should have it as the moon has the most mass, then the mountains, then a building, and then the basketball. Okay, so the next question is explain your answers. Basically, you know this because the more mass an object has, the greater the gravitational pull. So you would write the moon is the most massive object, so it has the most gravitational pull. The basketball is the smallest object, so it has the least gravitational pull. So explain what happens to an object when you drop it on Earth. In what direction does it fall, and why does this happen? So for us, it appears to just fall down, right? But is down the same for every single person? No, it falls to the center of the earth, right? So when you drop an object on Earth, it falls to the ground towards the center of the earth. This happens because the Earth's gravity is pulling the objects toward its center. Okay, so here, remember way back when we did a cause and effect. So in your answer for 3, which part is the cause and which part is the effect? So what is it? The Earth's gravity is pulling the object towards its center, and the effect is the objects fall to the ground. All right, so our key idea, I want you to copy this down. Objects that are initially not moving fall downward when released. So there must be a force, gravity, acting on the object. Because the Earth is very massive, the Earth has a strong gravitational force and pulls objects toward its center. Okay, so the 2 main concepts you need from this lesson is everything falls to the center of the Earth. Not necessarily, I mean, it does appear to fall down to us because the center of Earth is at our feet, right? Now, the second thing you need to know is that things with a greater mass have a greater gravitational pull, and a perfect example for that would be as if you just tried to pick up like a chair in the room, in my classroom. You try to pick it up, it's pretty easy, right? And then you have those great big tables in my room. Which one has more mass? Obviously the table has more mass, so it has more gravity pulling on it, so it's harder to pick up. Hope that makes sense. So your homework is to complete page 5. You got it, kids.